So howdy and welcome back. We'll continue our discussion with trying to recover from a formatted read error, and we'll go ahead and then actually in the next video get into the actual recovering. I want to spend a little bit of time here just to point out the implications of one common mistake, and then we'll get into resolving that within the second video here. So let's get started. So this code looks probably familiar. It was used in the last video. What we're essentially doing here is we're binding IFS to this file data.dat, which contains a white space delimited list of integer values with a character somewhere within them. And what we're using this for is assuming that that A should have really been an integer value, and we're going to expect that the format of our file will be all integers, and then we'll deal with at least try to deal with and handle the formatted read error that will result when we're expecting an integer object, but we actually get something that isn't an integer, in this case, a character A. So we go ahead and initialize value, which we'll be reading into. And notice here that essentially we're going to continue reading from our stream IFS while it's good. We'll attempt the read, and then we're going to make a check here and go, hey, if that read failed, and I'm not even going to worry about so typically, and I'll show this in the last video, typically the workflow is check if it's bad, and then by process of elimination, if you check that it's failed, you definitely know that the error that's being observed is recoverable. We're just going to jump right into it because I want to highlight something else here. So if IFS has failed, so if that last read into value did not succeed, I'm going to call this clear function, and I'll explain what it's doing here in a second, but just read the name and think about the process from the last video and what you would assume on first impression clear is doing, and then I'll tell you what it actually is. So let's go ahead and just get into this. So IFS, we have the contents of the file in the stream, and we're going to begin reading or attempting to read into value. So 1, that's an integer object. It can be interpreted as such. It meets our format, and 1 would be output to standard output. We see the white space delimited, so we know our reading of value is finished. And then we continue on. We now look at 2. We go ahead and begin reading from the stream. This meets our expectation of an integer. Okay, we hit the white space. We know we're done reading in this second value 2. It's output to standard output, and then we're at the character. And this is where things get interesting. So since the last read succeeded, the stream state is still good, and we hit this line where we're attempting to read, we're expecting an integer object, and we're getting a format mismatch because we're essentially latched onto a character. So what happens? At this point, as shown before, a bunch of warning bells go off. The stream state shifts from good to being in the fail state. So good would evaluate to false. Fail would go ahead and evaluate to true, because in this particular instance, we have a format mismatch, and that is indeed recoverable. So we began attempting our recovery process. We opened up the API, and we saw this clear thing, and we thought, hey, we might be able to use it to get by A and actually get over to 3 and read in our last sort of data while ignoring this potentially incorrect character inadvertently perhaps added to our file or whatever. So we get into the fail block, we execute clear on IFS, and we notice that the implications of this is that the state of the stream is reset. So we're going to see here that all clear does is it sets the state of the stream back to good, which means when we come up to here, the state of the stream is good. So we're going to hit the body of the loop again. However, remember that kind of extraction arm that's going out and pulling stuff out of the stream? we'll see that it's still latched onto A, and this is going to be problematic. Notice that on the failed read, though, I did write in that, hey, assuming that the IF stream can handle an incorrect read on this, it got the 0 value of the type. So we hit the cout statement, 0 is outputted because this line gets executed every time. The current state of the stream is good, so we're back in the while loop and we're attempting a read. And guess what? That arm's still latched onto A, and we attempt that read again, and it's going to fail. So in this case, we hit our fail block again. We call clear. Guess what? We've reset the stream state to good. That read failed. Value gets the 0 value of the type, 0. And then we go ahead and stream state's good again. So we get into the body again. And at this point, you can see here, we're starting to get into an infinite loop with zeros just being repeatedly written out to standard output. So this would continue forever because the extraction operator is still latched onto that character. And each time we're simply resetting the state of the stream, which means we'll get into the while body again, we'll fail, we'll reset the stream, and this process is endless. So what we'll see in the next video is, well, what if I want to reset the state of the stream, which I need to do if I want to jump over this invalid character here, but I also need to actually ignore that or have the extraction arm release A, let it flow by so that we can have an attempt at actually getting something else under our evaluation, in this case 3. So we'll go ahead and move into that here in the next video in our sequence.